Hello everyone, my name is Ona Dagiberbonet, and today I'll be presenting to you the paper The OPUS-MT Dashboard, a toolkit for a systematic evaluation of open translation models. First, I will walk you through the paper, and later I will showcase the demo. To get started, let's first look at the motivation that prompted the design of our tool. The current scenario of machine translation, with the increasingly availability of large language models and machine translation systems, it is making rather difficult to get the big picture of current MT systems and their performance, especially for particular language pairs. Moreover, reported results are usually not explicitly verified by a careful replication study, and finally, they are often presented for selected benchmarks, and cross-domain evaluation is often lacking. Just as an example, if we look at figure 1, we can see the difference in COMET scores between two models across different benchmarks. While some model may work very well for a specific domain, it may do poorly in any other distribution sets. Therefore, our dashboard provides a systematic evaluation to monitor machine translation progress and support model selection in practical applications. Now let's look at the previous work that exists in regards to our tool. Some previous tools exist addressing the issue of benchmarking for machine learning and natural language processing in general. This is the case with Papers with Code, Evaluation on the Hub from Huggingface, and DynaBench for dynamic benchmarking. Specifically targeted at machine translation, there was the WMT matrix, which is no longer available, and there exist the open source tools MT Comparable and CompareMT. On the commercial side, Intento is a company that every year issues a report with the evaluation of the performance of current state-of-the-art MT systems. But when it comes to define a tool for machine translation evaluation, Von Vera et al. Published a paper last year where they identify three main challenges. The main one is reproducibility, which refers to the replicability of a model's performance. Second one is centralization. Such a tool should be a single point of reference and could avoid, potentially, the duplication of work. And finally, coverage, the inclusion of a diverse set of metrics and languages, as well as pointers for efficiency, bias, and robustness. The OPUS-MT dashboard aims at addressing these three challenges. Our dashboard relies on two main ingredients. The first one of them is benchmarks, the test sets that we use for evaluation of models. We collect public benchmarks such as shared tasks from WMT, TICO19, the Tatoeba Translation Challenge, Flores, and so on. And the test sets cover in total over 44,000 language directions. In figure 2, you can see the distribution of languages covered in public benchmarks by the number of available test sets per language. It is no surprise that English is present in so many benchmarks, while there are other languages that are only present in one or two benchmarks. That is why we encourage the community to contribute with their own benchmarks to hopefully change this picture. The second main ingredient for our dashboard to work is the definition of which models we want to evaluate. We focus on three different types of models, each of them is stored in a separate GitHub, and the structure that they follow is very similar. We have the possibility to use user-contributed translations, and we also include OPUS-MT models, our internal models, and external ones. Let's look a bit deeper into these last two. OPUS-MT models actually refer to two different types of models: OPUS-MT, trained on different data selections from Opus, and Tatoeba models, trained specifically for the Tatoeba Translation Challenge. Then, for the external models, we wanted to compare OPUS-MT models to other state-of-the-art models, and we decided to include external models from Huggingface. To do so, we defined a pipeline making use of the tags that the hub allows. So first we looked for all of those models who had the tag text-to-text generation or translation, and then we removed the Helsinki NLP models, our models, from those. Then we further looked at the tags that the models contain and selected all of those models that have at least two language tags. In this case, this only represents 3% of all of the models that would be potential candidates, but the lack of metadata in the hub is far beyond our reach. Finally, we use a naive but rather effective approach where we identify the language direction of the model by using regular expressions from the model's names. Furthermore, we target specific external multilingual models such as the No Language Left Behind, M2M and multilingual BART. That is the reason why if we look at this table and focus on the language pairs per model, we can see that the external models are highly multilingual, and that's why they produce so many translations, whereas the OPUS-MT models are mostly bilingual, as it's shown in this table. Finally, for the contributed user translations, the dashboard also offers the possibility that if you have your own translations for a specific benchmark, you can add them easily, or, for example, for models that are very computationally expensive to run, the translations can also just be added so that we don't need to run them ourselves. In any case, the user-contributed translations are always kept separately because they are less reliable, as we didn't run the translations ourselves, we just evaluated them. Finally, let's look at the dashboard itself, the tool this paper is about, and this is really how it looks, but I think that it's better if we just try it out and show it live. So this is the main start page of the dashboard, and it is a light web interface that can easily be accessed at this link, and it has two main functionalities. The first functionality is the one that you can see here, which is to offer benchmark summaries over a specific language pair. These benchmark summaries can be browsed in different views. This is the first one, where we have a specific language pair, in this case English to French, and here we have all of the available benchmarks for this specific language pair. And then here we can see the best performing models for each of the benchmarks. If we click to a specific benchmark, we also can obtain the scores of all of the available models that we have. And this we can visualize in different metrics, for example, bleu, sentence B bleu, charf, charf++, and comment. Another functionality that we can do is that we compare models, for example, OPUS-MT model and an external one, and we can also plot this visualization in terms of difference. Now, if we go back to the main page, you can see that we can always include user-contributed scores separately through this link. The second main functionality that we have is to be able to browse the output of an actual translation. So if we click to a specific model, we can visualize the output that the model has produced. So in this case, we have the source, the reference, and then the model's actual translation. And we can highlight the difference between the reference and the model. Furthermore, this can be easily extended with a second model. And we can also compare their differences. Being able to browse the differences between two models is really enlightening to understand where our model may be having some failures. So this has been the demo so far. Let us recap to finalize our video. We have presented OPUS-MT Dashboard, a machine translation evaluation platform that includes over 44,000 language directions, where we include results for over 2,400 models covering 4,500 language directions and almost 300 languages. We hope that these numbers just keep increasing. The dashboard provides summaries of MT performance and the inspection of translation output, and can be consulted at this link. So I think that this has been all from my side. I can wait to meet you all at the conference and hear your feedback. Thank you so much. Have a nice day.